G'day, welcome to ECTE351 Group Project, the quality checker for production lines, kindly sponsored by III. As you'll see through the remainder of this video, we are not just selling a computer vision model, but a means to create your own and train it on your own data.
The project required a conveyor belt system to automate the process. This was achieved by gearing together multiple belts, all driven efficiently by two synchronized motors to ensure smooth, continuous material movement.
In order to drive the conveyor belt, we've gone with a simple 12-volt DC motor with variable speed control through PWM. This setup involves 3 boards, 2 motor drivers and a single control board. The control board generates a PWM signal based on the potentiometer position. The signal is forwarded to the motor driving boards, which convert the 5-volt signal into a 12-volt signal capable of larger currents. This is a short demonstration of how the system works. Notice the rotor speed changes as the position of the potentiometer changes.
This custom 3D printed enclosure houses the components for our QUACK system. At its core is a Raspberry Pi camera module mounted precisely above the working area, connected to a Raspberry Pi 5. The Raspberry Pi transmits image data through wiring to an ASUS NUC housed within the same enclosure, where the NUC does all the heavy lifting. All internal wiring is routed neatly through hollow sections built into the enclosure wall, keeping the setup clean and protected. Mounted on top of the ASUS NUC is a touchscreen display in its own custom protective case. Together, this enclosure brings all necessary components together in protective and complete unit.
The camera feed tab controls our live stream. The media folder is set to access the Raspberry Pi camera by default and can be changed if required. The Start Stream button launches the camera in real time, and the live feed can be locally accessed on a web URL. The real-time filtering can be started alongside to apply object detection instantly.
After new footage has been captured through the GUI, the script automateKdenLive.py can be triggered. AutomateKdenLive.py opens the modified Kdenlive file, preloading it with a search query based on the new footage's file name. At this stage, the user has a choice. Either they can accept the default footage that has just been captured, or they can swap it out for a different video if needed. If the captured footage wasn't already filtered, the user can apply a range of filters in Kdenlive. Once the footage is filtered and ready, the user can begin labeling different parts of the video. These labels can be assigned dynamically and will influence the dataset, described in data.yaml. Bounding boxes are drawn using Kdenlive's transform effect. Once the labeling is complete, the project is rendered as a PNG image sequence. This becomes the training dataset for the AI model.
Based on the data collected, pre-processed and labeled, the next step requires a decent amount of compute. We utilize libraries such as PyTorch, OpenCV, as well as NumPy to handle the data and train the model using it. This model is then exported to OpenVINO format, which operates best on our Intel-based NUC, kindly provided by our industry sponsors III. The primary step in this process is the inference, which uses the model trained previously on not before seen real-time data, provided through the camera. It then infers the class of the input based on the labeling of the data provided during training, as well as provide a confidence interval. With this system, models for any type of product can be trained and utilized with relative ease.
The impact of a quality assessment camera kit extends across ethical, environmental, and industrial areas. By ensuring data security and accurate defect detection, we reduce risks of industrial espionage and product recalls. Using biodegradable materials and energy-efficient AI processing, we promote sustainability and ethical engineering practice. Overall, the system delivers a reliable, transparent, and environmentally responsible solution that aligns with the Engineers Australia Code of Ethics and supports long-term industrial efficiency.
Thanks everybody for watching. We hope you'll visit our store at the Innovation Fair.